Hello, everybody. Welcome to lab. How we doing? I'm still looking for a few of the last lab, so please try to get that in soon. I know it was a heavy one, so let's. And I'm willing to work with everybody because I know that this lab switching to online was not an ideal scenario. A lot of this would be a lot different if we could do it in person. Um, but we'll fight through it. Just try to keep up. Don't get too far back, and we'll work with you to try to make sure everything works out. So what I'm thinking is let's check out played boundaries and then maybe stick like a little quiz in that kind of covers some of the stuff we've done. That will be through Brightspace, and maybe I'll do that because I didn't get this one up until today, Tuesday. Maybe we'll do that through next week a bit and just make sure that we're not trying to go too fast. I'd rather not have everybody panic versus speeding through it all. And some of you are caught up and looking great, so that way you get an extra minute to work on this one. So stay tuned. Let's start working on this one. Finish up the old work first, then start working on this one. And next week we'll kind of reassess and see where we're at. So this one, plate boundaries. So in class, if you're in my class, plate boundary stuff, those videos are going up today and tomorrow. Again, this is the 13th and 14th. I would check some of those out first. If you're not in my class, I'm hoping that you've done plate boundaries so far. What we're going to look at is the idea that Earth's lithosphere is broken into all these big chunks, and these chunks are moving in relative senses to each other, either like this, towards each other, away from each other, or sliding past each other. And that results in different landscapes, different landforms, some of the mountain ranges or rift valleys and ocean basins that we have. Again, the class will be more detail on that, but we're going to look in the lab at some of the specific things that we've noticed that help develop this theory and some of the specific things that we have on the Earth now because of it. So use the diagrams as you go. Hopefully this all makes sense. Good questions by email last week, so just please feel free to shoot me an email anytime, and we'll get to the bottom of any questions. I'm hoping this one's easier than last week's. Last week's was a little tougher. So yeah, I think the first two aren't too bad. Check those out. This will have a table on the answer sheet. We'll do this like the other ones. This is a PDF, and then there will be an answer sheet in Google Docs. And there will be a little table where you got to talk about the three types of boundaries and then match these pressures with them and these faults with them. It's really just copying off of this, but a little bit of just, hey, that'll show us what's going on. The three types of boundaries are listed right there. Then some reading out of a different lab source that I used to use. So check this out. Take a minute with that. Go back and look at what you did. Make sure that you got that right. And a couple of questions here. Those were all fairly straightforward. The idea with this lab was that you use tracing paper and trace the edges, but we can't do that online. So check out those two questions about what took place here in this part of the Earth with seafloor spreading. And then we get into the magnetic anomaly stuff. So here's the deal with this. Occasionally throughout Earth's history, and this should be in the course too, Earth's poles, magnetic poles, have flip-flopped back and forth. And that's recorded in the basaltic ocean floor. And the timing of it's not regular. It's a little bit irregular. And it's allowed us, basically the ocean floor has a full history of all of the magnetic anomalies during the time that ocean basin formed. So you're going to measure some of those. And I know the measuring on the computer is probably not super easy to do, but you can use where to go. This thing right here, and either a piece of paper or a little ruler, and try to make measurements. Remember that if you zoom in and then zoom out, that would screw your scale up. You got to pick one level of zoom and kind of stick with it. So if you do it at this scale, then measure at the scale, see how you can do with that, acknowledging that it's a little bit tricky to do. I won't be going crazy about making sure that you're accurate to the nearest tiny little bit. Get close and we'll be okay. All right, then it talks a little bit about where spreading happens and how those ridges, again, my videos in class will help you out, and I'm hoping that you did that in the other one as well. Yeah, so none of those should be too bad. There's the measurement ones. And here's what they would look like as they spread out. So this is like reading a infographic here, where we've got age going out and distance and looking at two separate places. A couple questions that relate to that. And there was one I was going to cross off here, but if it's on the answer sheet, I'll write skip for the ones that I have you skip. Further evidence is with the Hawaiian Island chain. What's going on here is that we've got a hotspot, and this is all in this. Whoops, sorry about that. This is in this reading here. Check it out. That is pumping magma out as we speak, creating the largest Hawaiian island, and then a new one is going to be forming down here. And then through time, as this plate moves off in the direction of that arrow, the islands get cut off from the hotspot, like the plumbing is disconnected. So from there, the volcanoes all go inactive. Then all that's left to happen is wind, waves, rain, everything beating up those islands, making them smaller and smaller and smaller through time as the plate slowly drags them away. So you'll have a couple questions with that, and again, more measuring to say how fast is it going. If this is present, and these are old ones with the ages printed right on there. That's a 5.1 if you can't quite make it out. 2.35, 1.83, and 1.32. And then now we do zoom way out. All of that Hawaii stuff is just this little section right here. This whole ridge is thought to have come from that hotspot. And you can see there's a little bend in the ridge. So something had to happen here where the direction changed. And you'll think about that a little bit in some of the questions. Subduction. Quickly go back to what you said on question 2. That's what I said. Whatever you do to back question 2 towards the top of this lab, use that to try to explain what's going on here. And then a little bit of transform, and again, more measuring, where you'll say, if this is sliding this way, if that green matched that green, how far has it moved and over how much time? Just more stuff with pace. I'll copy that into the answer sheet in Google Docs. And that should do it. All right. I know 15 pages looks like a lot, but a lot of them are just big maps. So it shouldn't be as terrifying as that. 15 questions over 15 pages. Should be doable. But again, anytime, please email and we'll get things sorted out. And hope everybody's doing well. Good luck with this week's lab. We'll talk to you soon.